Tesla isn't just building robots. They're reshaping what it means to manufacture at scale. And at the heart of this transformation is Optimus Gen 3, a humanoid robot that might become as common in homes and factories as the smartphone is in your pocket. But how did Tesla get here so quickly? It all goes back to their cars. Every breakthrough they made for their electric vehicles, whether it was in batteries, electric motors, gearboxes, AI chips, or advanced software, wasn't just about making cars. It was about building a foundation for something bigger, something human-shaped. Optimus Gen 3 isn't just a minor improvement over earlier prototypes. It's a complete rethinking of what a robot should be if it's going to be mass-produced. And mass production is the key word here. Elon Musk has been clear about this. Building a prototype is one thing. Manufacturing it in the tens of thousands, or eventually millions, is the real game. And Tesla thinks they've cracked that code. To understand how, look at what's changed. The original version of Optimus had over 600 parts, everything from micromotors to joints and dozens of screws. It was complex, slow to assemble, and difficult to scale. The new Gen 3 model? It has fewer than 200 parts. That's a massive reduction, and it makes assembly much faster and cheaper. Tesla's engineers achieved this by using modular castings and 3D printed components, simplifying areas like the chest, knees, and elbows. These aren't just design tweaks, they're production miracles. Some parts of the robot are now made using Tesla's famous Gigapress, a machine that can shape massive metal structures in seconds. In fact, it can now produce an entire torso module in under a minute. This kind of speed is unheard of in the robotics world. Tesla isn't building a new factory to do all this either. Instead, they're repurposing their existing car factories, especially Gigafactory, and turning them into hybrid facilities where both cars and robots are born. Welding robots that once worked on Model Ys are now assembling Optimus joints. Paint booths that used to coat Cybertrucks are now giving robots their sleek finish. Inspection cameras that checked car doors now examine robot limbs. It's all happening under the same roof, using the same tools, but for a completely new product. By leveraging their existing ecosystem, Tesla avoids the massive cost of building a factory from scratch. They also speed up the development cycle. If they need to make a change, they don't need to retool an entire supply chain. They just adjust the software or print a new part. Tesla is also leaning heavily on 3D printing. For more complex components like the robot's chest, shoulders, and knees, 3D printing offers not just precision but speed. The turnaround time from design to a functional part has dropped to just 3 to 5 days. At Gigafactory, their industrial 3D printers are already pushing out around 5,000 components each week. That kind of output supports their goal of producing 10,000 robots a month by late 2025. But it's not just about building fast, it's about building smart. The software that runs Optimus is derived from Tesla's self-driving technology. The same AI that helps a Tesla navigate traffic now helps the robot process its surroundings, make decisions, and learn. That's another huge cost saver. While other robotics companies develop new software from scratch, Tesla reuses what's already proven and field-tested. And they're not waiting for perfection to begin deployment. In 2024, 2 Optimus Gen 2 robots were already being tested inside Tesla's Fremont factory. They performed basic tasks like carrying parts and assisting on the assembly line. This real-world testing isn't just for show, it's a trial run for massive internal deployment. Musk has said thousands of these robots will be working inside Tesla factories by the end of 2025. Compared to other robotics companies, Tesla's approach is radically different. Take Boston Dynamics, for example. Their robots are stunning to watch but are built mostly by hand and at a high cost. Their Spot robot sells for around $75,000, and their humanoid Atlas isn't even for sale. Figure AI, backed by big names like Amazon and OpenAI, is still struggling to bring costs below $50,000 per unit. Tesla's Gen 3 is targeting less than half that, under $20,000, with ambitions to go even lower, through design efficiency, vertical integration, and scale. Tesla doesn't outsource components like motors or AI chips. They build them in-house. They don't rely on third-party software, they write their own. And they don't make hundreds of units, they aim for hundreds of thousands. According to industry insiders, with enough volume, say around 500,000 robots per year, Tesla could bring the cost per unit down to $14,000 or even $10,000. That's less than the average car. And if Tesla follows its usual playbook, it might even offer Optimus on a subscription model. Instead of buying a robot outright, you could rent one for household tasks, elder care, or even personal assistance. It's like having a digital butler, one that upgrades itself through over-the-air updates and learns new skills on the fly. Materials have also changed. Tesla has shifted from traditional aluminum and steel to advanced alloys and polymers, many of which can be molded or 3D printed quickly. This not only reduces cost but also trims weight. The Gen 3 is about 10 kilograms lighter than earlier versions, making it safer and more agile. Every part of this redesign points toward mass adoption. With fewer parts, faster assembly, and integrated systems, the Gen 3 isn't a lab prototype, it's a real product ready for the world. And Musk believes it's just the beginning. He's predicted that by 2027, Tesla could produce between 500,000 and 1 million Optimus units annually. If that happens, it won't just be a success story. It'll be a revolution. And not just for Tesla. For the robotics industry, for manufacturing, for households across the globe, Optimus Gen 3 could be the moment where science fiction quietly slips into everyday life. As it stands today, Tesla is the only company with the scale, infrastructure, and speed to make humanoid robots a practical reality. Other companies are still trying to solve for design or software. Tesla already has both. And thanks to its vertically integrated approach, it controls every part of the process, from chips and software to factories and robots. This isn't just about building robots. It's about building the future workforce. And in classic Tesla style, they're doing it fast, efficiently, and with their eye on the long game. If the Gen 3 rollout continues at this pace, it won't be long before having a robot in your home is as normal as having a smart speaker or an electric car. And when that happens, we'll look back on this moment as the true beginning of the robot age.